Okay, so in pig, how can we perform word count? Let me open up pig here. So we will connect to SDFS only. We have input data there, and as I told you, in pig basically the data has to be explicitly stored, otherwise it will get wiped off. Okay, it will not remain. As soon as you come out of pig, nothing will be there. Okay, so let us get into pig and try that. Okay, it is connecting to SDFS. Okay, so as I told you that the first thing is we need to load that data, right? Load that data. So we are creating a relation called as input lines. Okay, a relation we are creating, input lines. So let me create that relation, input underscore lines. So this is a relation, okay, is equal to load. Okay, and what we are loading we'll have to write here. Okay, so we are loading, there are 3 files, right? There were 3 files. So let me just write slash word count slash input input. We are just loading this, and we are putting it as line is a column, char array. So I'll put here as, in bracket, line char array. Okay, so let me first check whether this will get loaded or not, just in order to avoid the errors. So let me dump input lines and check whether that data is loaded or not. %50 complete. Okay, successfully loaded, right? So step 1 is done, fine. Then once the data is loaded, then we have some ready-made functions which will help us to tokenize the word and split them into multiple rows. Okay, I'll keep on showing you the output so that you understand. So now here I am creating another relation, that is words. First is understood, right? We have loaded the data. Now I am creating a relation words is equal to for each first relation is input lines. Okay, so for each input lines, what do we need to do? Generate means produce something, and what we are producing? Flatten tokenize line as word. Flatten tokenize line as word. Tokenize means splitting by default with the help of white space, splitting. Flatten means, let's say we have a word here, refund. Okay, tokenize will produce refund, will be 1 atom, tax will be another atom, bill will be another atom, and so on. Currently, refund, tax, bill, invoice, discount is 1 atom. Are you getting? Currently, this is 1 atom. The whole line is 1 atom. Otherwise, you should have got comma in between. If you would have multiple atoms, there should have been refund, comma, tax, comma. This way you should have got. But that's a 1 atom. So that atom will get splitted. You have multiple atoms. Now, all your atoms will get converted into multiple rows. Refund will be 1 row, tax will be another row, bill will be another row. Okay, why we are doing this? Because we have a query group by. So we will group by and we will get the count easily. Therefore, we are generating rows out of them. Okay, that's why we have put this function. So here we will generate few keywords are basically case sensitive. and rest keywords are not. Okay, so flatten, tokenize, and the column name was line, I think. Column name was line, and we were making a column name as a word. So let me dump this as well. Dump words. Let's see what do we get. So we should get each word in a single row. Okay, for every word there will be a row. That is what we should get. No, I said few keywords are case sensitive, few are not. For example, load, you can write small and caps as well. Flatten, you have to write capital only, you cannot write small. Okay, so few keywords are case sensitive, few are not. Maybe like next releases you may find some standard, like either both are not both are case insensitive. That way also you can find. So here you have got all the words with like they are exported as a single row. Okay, they are tokenized, and with the help of flatten function we have got them in a separate row. Now after this we will perform a group by on it. So for group by, we have a relation word groups is equal to group words by word. Words is your previous relation. By word is your column. Okay, so now if I do describe words, so words is the relation where these words are present, and inside words relation we have a column words. Sorry, we have a column word. We have only one column. Word is a column. Okay. So what we are doing, the relation name is word groups. Word groups is equal to, yes, what we will do, group words by word. Now let us see what is the output, and now we should get bags because we are grouping. So tuples are there, tags is a tuple, so there are multiple tuples having tags, they will be grouped, so we'll get a bag. So let us dump it, dump word groups, we should get a bag. So it's all running MapReduce. Okay, so here in the browser also we should be able to see something. Yeah, some job is running now also, MapReduce job, right? So these are pick jobs. So what we discussed is actually true, that pick job is actually getting converted into MapReduce. Whatever jobs we have run, they are listed here. The first one was word count, and rest all are pick jobs. Okay, wherever MapReduce was required, it has been running that. Okay, now this one is going on, that is also done. Fine. So yes, we are getting bags here. So here if you see bag, tags is one, and this is a bag. Okay, where multiple tags are tuples are being included. Fine. Now next is we will perform count for. Yes, so word count for each word groups, generate group and count words. So let us describe this first. Describe, and what was the relation name? Word groups. Word groups. So here if you see describe word groups, word group has got group as char array and words as a bag. So group is nothing but discount is value in group, invoice is value in group, refund is value in group, right? And words, so after discount, this is word. There are two columns, right? Are you getting? Bag is a column. Bag is one, again bag is like a tuple. Sorry, bag is like an atom. An atom. Okay. So discount is one atom and this whole is another atom. And this atom itself is a bag. Right? Do you understand or not? You understand? Okay? Fine. So now your group query generates bags. The feature of group query is to generate bag, because group combines your tuples, and if your tuples are combined, it becomes a bag. Okay, fine. So now we'll make a relation word count. For each word group, generate group and count words. So word count for each word groups generate group and count words. Now dump word count. So we should get the word count. Okay. Now I'll have to store this into a file, otherwise this will wipe off if I come out of the shell. Okay. It is 50% completed. Okay, done. So we got the word count, right? Yeah. Yeah, we can run scripts as well. We can write script and we can run that as well. That is also possible. For every like for Hive also we can write, for this also we can write, and we can run the whole script. That is what I said, like we should ideally write scripts so that we have the code saved with us. Okay. So now if you want to store it, yeah, this is a way you can store. Here basically we have stored store ordered word count. Just a second, ordered word count is not generated. Fine. So here only word count will come. Here word count, store word count into output 3. Okay, using quick storage and comma is given. So if you will not give comma, it will take default. Okay, usually tab is the default. Okay, so let us store that. Store the last relation was word count. So store word count into we will do under word count slash pig wc output. Okay, under that let us put it. Okay, so it is putting. So by default whatever delimiter is there, it will take. And let us go to the browser now, and here word count pig wcop directory is created. It is still working, still not generated. %, done. Okay, done. So word count has been given as output, right? Okay, so this is in pig. This is how it happens in pig. Okay.